Yeah, so we're getting into our quadratic functions unit. We only have 2 units left, and then we'll be done the course. Yeah, so quadratics and then trigonometry is it. So with quadratics, it's just going to be an overview of what is a quadratic function, and we're going to rely on Desmos a lot for the graphing. So as I mentioned, we're just going to go through this together, but I'll give you time on Monday to copy it in your lesson workbook. And I'll have you define these terms using a textbook on Monday. Okay.
Okay.
So we'll just start here. So this is showing a soccer ball that is kicked into the air. I think you can imagine what that path looks like, right? And if you watch the video, you know that a quadratic function is one in which it has like a parabolic shape. So the soccer ball gets kicked, it goes up, and then it lands back down on the ground, right?
Yep.
And this is due to gravity. So any kind of a projectile, a soccer ball being kicked, a basketball being thrown, a volleyball being bumped, a firework being launched.
When it showed the Angry Birds, I was like, I feel so old because I used to play that.
Yeah, I love Angry Birds, and it's all parabolas. It's like, how high do you want it to go, or how low do you want it to go, right?
Yeah.
I love Angry Birds. So in this question, it says that we have a soccer ball and we have a table of values. I'm going to just graph it on Desmos, Maya, and then we're going to just check and see what does that look like, and then we're going to try to analyze the data. So yeah, anytime I ask you to graph in this unit, just go ahead and use Desmos. So I'm going to switch my screen. Can you read me that? No, I'll have to switch back and forth because you don't have that written down anywhere.
I mean, like, you could do something. I just won't see it, and then like I could just read this off while you do that. While you do the Desmos thing.
Let's do that. That's a great idea. Okay, so if I do this, can you still see that table of values?
Yes, I can still see the table of values.
Wonderful.
You just have to share your screen again.
Yeah, good teamwork. Okay, so what's the table of values say, Maya?
For time, do you want the time first or do you want like both?
Yeah, so 0 and then what?
Okay, so 0, 0.5.
0.5, okay.
What? 1?
Yeah.
1.5.
1.5, yeah.
2. 2.5.
Okay.
3. Now for the height, it's 0.10.
Okay.
7.80.
For which one?
For 0.5, sorry.
So for time 3 was, oh, okay, sorry, I've got this a little bit wrong.
Oh, sorry, I thought.
Okay. I got this. Okay. 1 second. Here we go. Okay, what's the height for time 0?
0.1.
Okay, and 0.5 is the height of?
7.80.
Okay, and then next?
12.
Okay, next?
13.80.
Okay, next?
Also 13.
Just 13?
Oh yeah, just 13, sorry.
Okay, 2.5?
9.75.
Okay, and then 3 seconds?
4.
Okay. Okay, so let me share the graph. We'll take a look
all
here.
my classes, my math and vocals class has to be the most chill because I have so much to do in my apps and English class at the moment.
Okay, so see how the soccer ball went up and it came back down here?
Yep.
Based on that graph. So I'm actually gonna grab it. We'll put it in our notes here. And then you can see that it is a parabolic function because it reached a maximum point and then came back down to the ground, like we know would happen in real life. Okay, so copy that and let's go back to question. So we used Desmos. I can put the graph in here. It's quite big.
Yeah. I hate it when like something is so spread out and you just like, it just makes it look really big or something.
Okay, there we go. Now the first question it says, what's the shape of the graph? So do you remember from the video, what's the name of the shape for a quadratic function?
I don't know.
It's a parabola.
Okay.
Yeah, and so the word parabola just means that it's a symmetrical curve. In this case, it goes up. Ooh, I can't write on this picture. thought maybe I could. It won't let me draw on top of it, I don't think. Oh yeah, it will.
Oh,
It goes up, it hits a maximum, and then it comes back down to the ground like that. Okay. So this, in this case, it is a, oops. Here we go. The name of that shape is a parabola. And what's the maximum height of the ball?
13.75,
Good.
80?
Yeah.
No,
Yeah. And is it?
Oh, 80, never mind, not
And
75.
it's meters, 13.8 in meters. So this ball was kicked pretty hard. How many seconds was the ball in the air? Let me go back to the Desmos graph. So we're pretty much looking at when is the ball going to land on the ground.
It was...
So if I kind of continued this down, what do you think, Maya? Where is it going to land on the ground? It's going to go up, down. What do you think?
Around here-ish, I guess? Unless it bounces.
So maybe around like 3.5?
Maybe.
1, 2, 3, somewhere here, or 4? I think maybe 3.5.
Yeah.
Okay, so let's say 3.5 seconds.
Okay.
All right. And that's all we're doing with this question. It's just analyzing the shape of that soccer ball.
All right.
Instead of graphing this, we're going to try to see if this is a straight line, is this a parabola, or is it neither of the above, just based on the data itself. Does anybody remember what differences means in math?
Minus?
Yes, minus, good, or subtraction. Okay, so when you're trying to figure out the difference between the numbers, all you're doing is subtraction. So what is 6 take away 1?
5.
Good. What is 9 take away 6?
3.
What is 10 take away 9?
1.
What is 9 take away 10? -1. Now we're going in the negatives. What's 6 take away 9?
-3.
Good. And what's 1 take away 6?
-5.
Perfect. If these numbers were the same, if this went 5, 5, 5, 5, 5, 5, this would be linear. But these are not the same. It's not going up by a constant amount. It's going up and then it's going down. So what we're going to do is we're going to do differences again of these new numbers, and we're going to see if the pattern emerges. So now I'm going to do 3 take away 5.
-2.
Good. Now I'm going to do 1 take away 3. -2. What's -1 take away 1?
Oh, is that -2?
Yeah.
All right, so everything.
What's -3 minus -1? So this is the same thing as -3 plus 1.
-2.
Awesome. You're seeing the pattern. -5 minus -3. That double negative is a plus.
-2.
2. When you're the second time you do this, when that is all the same number, then you conclude that the data is quadratic. So if the first differences are the same, the first time you do it, if it's the same, then it's going to be linear. If the second differences are the same, then it's quadratic. But if neither of them is the same, then it's neither. So first differences are the same equals linear. Oh, you can see I'm having a hard time typing today. Second differences are the same equals quadratic. Neither difference is the same equals neither. That's an easy one to remember. All right. So this is just a quick, easy way of determining whether you're looking at quadratic data, linear data, or neither, which it could be exponential, like we've talked about already, exponential growth and decay. That could be an option, but for now we're just focusing on linear and quadratic. Any questions on first and second differences? Okay, this should be a quick, easy type of question. And if you're like kind of stuck on the subtraction, just do it all on your calculator. So let's try this one. What does 14 take away 12?
2.
Good. What does 16 take away 14?
2.
What does 18 take away 16?
2.
Good. What's 20 take away 18?
2.
This is good mental math, right? What's 22 take away 20?
2.
And 24 take away 22.
2.
So this is increasing at a constant amount. So what kind of a data do we have here?
It is consistent.
Yeah, so is it linear, quadratic, or neither?
I think it says quadratic.
Quadratic would be if we had to do it 2 times.
Oh, shoot, never mind.
Yeah, I'll write linear, and then I'm going to go back here for a second. So, and you guys can have these notes when you take your test here. If you only have to do it 1 time, Maya, it's going to be a linear function. If you have to do it 2 times, it's quadratic. If it doesn't ever work out to be the same number, then it's neither. Okay?
Okay.
Okay, let's try this one. What's -2 take away 9? So -2 take away 9 more.
-11.
Good. And Rachel, I would like to hear you talking as well. What's -11 take away -2? So this actually becomes -11 plus 2. Rachel, are you there? What's 7 take away -11? So 7 plus 11.
That's 18.
Good. What's 0 take away 7?
-7.
Good. What's -4 take away 0?
-4. Okay.
Good. And what's 15 minus -4? So 15 plus 4.
19.
Good. Now, obviously, Maya, these are not the same, right? So we have to try it again. I can -9 minus negative, so this is -9 plus 11, so 2. 18 minus -9, so plus is 27. You can already see this is already going to be.
That's going to be neither.
This is going to be neither. We can already tell because the first 2 were not the same.
They're very far apart.
These are
numbers.
Quite different. 23. So okay. So what's our end conclusion, Maya?
It's neither linear
or quadratic. Very good.
Yeah.
Yeah. Data is neither linear or quadratic. Good. Linear nor quadratic. This would be all over the place. It could be a random scatter plot based on those numbers, right, Maya? It's kind of all over the place.
Yeah.
Okay, so we have learned that a quadratic function makes a parabola, so it goes up and comes back down, or it comes down and goes back up, so it's a curve. We've learned that in order to determine if it's a second quadratic function, the second differences have to be the same. And now what we're going to do is we're going to try to relate the equations to the shape of the graph and make some conclusions based on the equation, okay? So Maya, I'm going to have you read me each of these equations. I'm going to put them in Desmos and then we'll take a look at them.
Okay.
So if you can tell me equation 1, y equals, is it?
3x plus 4.
Okay, what's your second equation?
Y equals 2x squared minus 5x plus 3.
And next equation.
Negative 4x squared plus 3x minus 4.
Okay, next equation.
Y equals 1.5x, or 1 divided by 2, x equals 5. I mean, negative 5, what?
Okay, minus 5?
Yep.
Okay. Fifth one?
Y equals negative 2 parentheses x minus 3 squared. That's a lot. And then plus 7.
Okay. Got it. And is that it, or is there more?
I can't, if there is more, I can't see it. I can only see up to 5.
Let me see. Oh, one more.
There's one more.
What's the last one?
Y equals 4x cubed minus 1. I forgot what you call the third one because usually that doesn't happen. So.
Yeah, we don't see that very much, do we?
No.
Okay. I'm going to just show you these graphs, and then we're going to try to make some conclusions here, okay? So you told me the first one was y equals 3x plus 4. Is this linear, quadratic, or neither?
I forgot.
Is it a straight line? Is it a curve? Or is it neither of the above?
Oh, well, it's a straight line, so it's linear.
Good. So this one is linear. I'll go back in the notes and write in a second, but y equals 3x plus 4 is a straight line. Okay. How about this one?
It's I forgot the word.
A quadratic, right? It's a parabola. Yeah, it makes like a smiley face. Awesome. Okay, so that one's quadratic. How about, where did this one go? That one.
Quadratic.
Good. And it's a frowny face, right? Like it's opening down, but it's still a curve, a perfect curve.
Yeah.
How about this one?
That's linear.
Good. How about this one?
That's quadratic.
Good. And how about that? That one.
Neither.
Yeah, exactly. Okay, so I'm actually going to take a screenshot of this. We'll put it in our notes just so you have it as a record. And then we're going to see.
That looks like a mess.
It does, doesn't it? But hopefully the colors help you figure out what's what here.
If they look like a different color because there's two black ones, like if they look completely different, I guess I'd be able to figure
there's
it
two
out.
black ones. Actually, I can change that.
Okay. Because I was thinking that did they run out of colors? Is that why they went back to black?
Yeah, let me just change it. Okay, so I'm going to just write down what we said. You guys can see my notes here, right? With the graph inserted in.
Your notes? No.
Oh, I got to switch the screen share. Thank you. How about this? Can you see that now?
Yes.
Okay, so the first one we said was linear.
I'm
going to try to match up the colors here as best I can. The second one we said was quadratic because it looks like a parabola. Quadratic. The third one we said was quadratic because it looks like a parabola. Quadratic. The fourth one we said was linear. It's a straight line. The fifth one we said was quadratic. My purple is not exactly the same, but we'll have to just go with it. And let me see if I can write in dot quadratic. Oh, we need a weekend, hey guys? Okay, and let me see if I can do, I can write in dotted lines. This one we said was neither. Look at that. Okay, I'm having too much fun with this. It's harder to read, but.
That looks like a zebra.
It does.
Okay, let's first look at the linear ones, okay? So linear was 1 and 4. Do you guys notice anything similar between the equations 1 and 4?
Between the equations 1 and 4?
So y equals 3x plus 4 and
well, they're both linear.
Yeah, but what do you notice about the equation itself? Does it have any exponents?
I forget how to identify that.
So does it have any of these small numbers up top?
Well, yes. Oh yeah, that's what exponents are. I'm sorry, I forgot. It's almost like I forgot the language of math.
That's okay.
Yes, they both do, it appears so. Wait, no, they don't.
Okay, good. So there's no exponent. I just have a y and an x in both of them, right?
Sorry, I was looking at the wrong question. Yeah, they both don't.
Okay. Okay, good. So linear will have no exponents. It's just going to have a y and an x relationship in it. Let's look at the quadratic ones, which we said were 2, 3, and 5. What do you notice about 2, 3, and 5 that might make them quadratic? What do they have in common?
They all have a square.
Yeah, they have a square. That's what makes it come up and then go down, or come down and then go up. That's what makes it have the curve, is the square, the exponent of 2 on it. And we only have one neither one. The neither one is the last one. What's different about the last one?
It's a cube.
It's a cube. Exactly. It has an exponent of 3. Okay, so we're going to try to make some solid conclusions here. Linear relationships. Linear has no exponents, just an equation with y and x. Okay. Quadratic has the highest exponent of 2. So it's squared. And neither, in this case, has an exponent higher than 2. It's a cube.
Yeah.
All right, let's, we're gonna play around with Desmos here just to make sure we have this like solidly in our mind here. What's the difference between them?
Yesterday for